In problem 6, with this jib crane, we were given a 4-meter beam pinned to the wall at A and tied with a cable at B. The crane supports a 10 kilonewton load applied at the 1/3 point of the beam, so that tells us this distance right here, that it's 4 meters long, so 1/3 would be 4/3 meters, or 1.33, right? Not 1/3 of 3 meters, but 1/3 of the entire. Ignore the self-weight of the beam, determine the force in the cable, and find the resultant reaction at A. Right, so let's go start off the problem as we always do with a free body diagram. And so I'm going to put it up here. There's our beam. And now we start putting forces on there. We've got the applied force of 10 kilonewtons. That's at 4/3 meters from the right. We've got the vertical reaction at A, and we've got a horizontal reaction at A, so AX, AY, and then we've got our cable force applied out here 3 meters away from the wall, and there's our T. Okay, now you could do this a lot of ways. Probably infinite number of ways actually, but what I'm going to do is I'm going to go find AX right off the bat by summing moments at a mythical point. Mythical because we haven't labeled it, but now I will. I'll label that as point B. The attachment point, we'll call that point C. That is very convenient because, note, if I sum moments about this point C, then the tension that's unknown goes away immediately. We've got 10 times we got to get some sign conventions here. Let's use counterclockwise. We've got a plus 10 times 4/3. AY goes right through C, so that goes away, and we'll have minus AX times, we don't know that moment arm. We need that distance right here. So, okay, we got 3 here. There's a 30 degrees there. Oh, hey, all right, this has to do with that whole tangent business, right? And so tangent of 30 is equal to opposite over adjacent. And so now we can get that that height is going to be 3 times 30 tangent, or 1.732. Of course, that equals square root of 3. Right? Just so happens the way that was all working out. And so that distance there for AX is square root of 3. That is set equal to 0 for equilibrium, and therefore AX is going to be then, solve for that, times 40 divided by 3, and we get AX is equal to 7.698. Okay, for an intermediate result. You could round that up probably to 7.7, not lose any resolution in this particular problem. Right? So then we could sum moments about point B, which I'll call, well, I kind of messed up my labeling here, didn't I? That was point C, that's point B, now that's really point C. Kind of confusing there. So backtrack there. To find AX, some moment about point C, that top point. And down here then some moments about point B to get what? Well, T goes through there, and AX will go through there. And notice how they cleverly drew this to indicate that where the line of action of the attachment point really went. And so AX goes through there. Well, we'll end up getting AY. Okay with that. Let's take counterclockwise positive again. We get 10 minus 10 times, that is, sorry, 10 times 3 minus 4/3. Right, so that's the moment arm here. And then we got to get the AY, so that's going to be plus 3 times AY equal to 0, so therefore AY is going to be 5.55. Repeating. Okay, and then that gives us 2 of them. We still need the cable force. I'm going to sum moments now about point A, and once again take counterclockwise positive for the heck of it. We'll get 10 times 4/3, and then minus, well, the x component of T goes right through the point, so I only need the y component of t, and that's going to be t times sine of 30. And then the moment arm will be, because now I've broken this up into that and that, right? So I'm going to come back and get the 3 meters, set it equal to 0. And of course, sine of 30 is 1/2. And so we get then 40 divided by 3 times 2 divided by 3. And the cable force T equals 8.888, repeating. And so final answer then that I would report would be that T is equal to 8.89 kilonewtons, that AX equals 7.70 kilonewtons acting to the left, and AY equals 5.56 kilonewtons acting up. Bam, there's your appropriately documented answers. Right? Now, we're not done, right? Because in this test, we also have to indicate whether we've abided by the course honor pledge. I have not tolerated the use of unauthorized aid right? And you need to absolutely know that pledge. If not, you and I will get to spend some quality time together where I'll start asking you serious questions about why you don't know that, or whether you're trying to indicate to me that actually you are honorable and you can't sign your name to this, so therefore you're going to spend time talking to me about what you did see.